Just before we get started today, my apologies for the pronunciation. Sometimes I'm looking them up when I can. I got my pronunciation dictionary ready, but they're not always there. It is what it is. It's Siberia, Russia, the 30th of June, 1908. We are in a woodland area surrounding the Tunguska River, not far from modern-day Krasnoyarsk. This area is just known as Tunguska, and it's one of the most desolate areas of the most desolate regions of the Russian Empire. It's a crisp, cloudless morning. All is quiet, but the event is about to happen. In a few minutes, the sky will open into, torn asunder by fire and the sound of thunder. A storm of time and space is going to descend from the sky and strike at the earth. Welcome to today's Geographics. Today we're going to explore Tunguska, an area whose name would be confined to the atlases if it wasn't for the mysterious event that lit the skies and shook the earth for a radius of 1,000 kilometers. It's an event and it's a mystery that would take 105 years of research before we could finally write the words, the end. 7:17 a.m., the 30th of June 1908, and a mysterious explosion occurs in the skies above the Tunguska River. 1,000 kilometers, that's 600 miles away from ground zero, seismic vibrations were recorded as intense as the 5th marking on the Richter scale. At 500 kilometers, 300 miles, witnesses reported deafening bangs and a fiery cloud rising above the horizon. At about 170 kilometers, that's 110 miles from the impact, just before the explosion, an object was spotted in the clear daytime sky as a brilliant sun-like fireball traveling at enormous speed, leaving a trail of thunderous noises. 60 kilometers, that's 40 miles from ground zero. At the time of the explosion, people were thrown to the ground by the shockwaves or even knocked unconscious. Windows shattered in a hail of shards, while furniture, crockery, and other objects fell to the ground. Now 30 kilometers or 20 miles from the site of the explosion, the closest inhabited area, a few moments before the blast, a group of reindeer herders are asleep in their tents. And then a sudden deflagration sends them flying through the air, knocking them unconscious. An elderly herder is sent flying for 12 meters, that's 40 feet, smashing into a tree, causing a compound fracture of his arm. He later dies from his injuries. Hundreds of the herder's reindeers are killed, and trees are set ablaze and fall to the ground, their tops pointing radially away from ground zero, like giant arrows. Another herder reported, "The ground shook and incredibly prolonged roaring was heard. Everything round about was shrouded in smoke and fog from burning falling trees. Eventually the noise died away and the winds dropped, but the forest went on burning. Many reindeers rushed away and were lost." So what happened? Eyewitnesses in Krasnoyarsk and nearby towns share the same recollection of a fireball flashing across the sky, reading as such: "A ball of fire coming down obliquely. A few minutes later we had a separate deafening crash like peals of thunder, followed by 8 loud bangs like gunshots. A ball of fire appeared in the sky. As it approached the ground, it looked like a flattened shape. A flying star with a fiery tail. Its tail disappeared into the air." After the object crossed the sky and approached the horizon, it was consistently described as a pillar of fire. The fireball appeared 2 or 3 times larger than the sun, but not as bright. The trail was like a fiery white stripe, its color sometimes changing to red and bluish-white. Some minutes after the explosion, distant observers reported a vertical column of smoke on the horizon. One observer said, "Where the body disappeared behind the horizon, a pillar of dark smoke rose up." It was unclear from reports whether the pillar was a mushroom-like cloud generated directly from the explosion or smoke from the forest fires. Days later, strange phenomena were observed in the sky of Russia and Europe, like glowing clouds, colorful sunsets, and a weak luminescence in the night. Unfortunately, the inaccessibility of the region and Russia's unstable political situation at the time prevented any further scientific investigation. It would take 19 years before mineralogist Leonard Kulik organized an expedition to investigate what may have happened. In 1921, Leonard Kulik, former soldier, revolutionary, and now professor of mineralogy, was charged with locating and examining meteorites that had fallen within the Soviet Union. While prepping for this expedition, he came across an account of an explosion in Tunguska, reprinted from an old newspaper. During his first expedition, Kulik only managed to figure out the general location of the blast area, but not actually visit it. He continued to collect stories about the events, and one in particular tickled his curiosity, from ethnographer I.M. Suslov. He had collected the story of a family living 25 miles from the blast. The entire group was thrown down by the force of the blast, and several were knocked unconscious. The wife reported that when they awoke, they found the forest blazing around them with many fallen trees. Some of the children described it as such: a terrible storm, so great it was difficult to stand. The trip was not an easy one. The maps were inaccurate, the compasses seemed to be confused, and the terrain was inhospitable. By the end of March, Kulik reached the town of Vanavara, located on the Tunguska River, the last outpost of civilization, before the expedition had to traverse the swampy forest where Kulik was sure to locate the site of the event. Kulik tried to interview the locals, but found that many of them did not like to discuss the event. The ethnic minority of the Tungus still had shamanic beliefs and were convinced that the event was a visitation of Ogdi, the local god of thunder. Ogdi had cursed the area by smashing trees and killing animals. No man now approached the site for fear of being cursed by this god. Kulik had to wait for the snow to melt in April, and then he continued on horseback, his party suffering from infections and malnutrition. After swapping horses for reindeer, they reached the Makirta River and saw the first evidence of the Tunguska blast: the fallen and charred trees. Kulik noticed that the trees had been burned from above. He was sure that it was the work of a sudden flash of intense heat and not a forest fire. As they approached the epicenter, the local guides grew wary of Ogdi's wrath, and they refused to continue. Kulik had to return to Vanavara to hire some new scouts. Kulik's expedition returned to the dead forest on the 20th of May. The direction of the fallen trees pointed towards ground zero of the blast, which Kulik finally located. It was an area known as the Southern Swamp. With the mind of a mineralogist, Kulik had formulated a simple hypothesis: the blast had been caused by a meteorite. But when he reached ground zero, what he found was not what he expected. First of all, there wasn't a crater, which made him ask the big question: well, how does that work? Moreover, at the epicenter of the blast, Kulik saw a standing forest of trunks, straight and tall, but charred and stripped of branches like telephone poles. The mystery, it was deepened by the eerie landscape. Kulik wrote, "The solid ground heaved outward from the spot in giant waves, like waves in water." Realizing that nothing more could be done on this trip, with only 3 or 4 days of food left, Kulik decided to leave. He returned for 2 more expeditions in 1929 and 1938, but both proved inconclusive. Everyone was wondering how there could be no crater. Another scientist, E.L. Krinov, returned in 1940. His theory was that the meteorite had exploded mid-air, hence the absence of a crater. What people were really wondering was whether this was possible, and more importantly, why couldn't anybody find any specimen of the meteoric rock? Unfortunately, though, the war put an end to his research, and Tunguska remained a mystery for many decades. The fact that the event was investigated so late, the scarcity of information outside of scientific circles, the secretive nature of Soviet regimes, all of these factors contributed to the proliferation of theories as to the exact nature of what really happened in Tunguska. Some theories are fascinatingly outlandish, others less so, but they are probably right. So let's start with theory number 1. Engineer and sci-fi writer Alexander Kansensus and Soviet scientist Alexei Zolotov argued that a nuclear explosion of possible extraterrestrial origin caused the Tunguska blast. Either a UFO crashed in Siberia due to a malfunction, or an interplanetary weapon was detonated there for unknown reasons. Kansensus also claims that geomagnetic anomalies that were recorded were similar to those of a nuclear blast. T.R. Lemaire, a science writer, continues this thought, but suggests that the blast's timing seems too fortuitous to be an accident. Calculating the rotation of the Earth, he claims that a 5-hour delay would make the target of destruction St. Petersburg, or a small change of trajectory would have devastated populated areas of China or India. Lemaire maintains that the flaming object was being expertly navigated. He said that it was using Lake Baikal as a reference point, and that it changed direction mid-flight twice. His fascinating conclusion is that the alleged aliens may have been on a bombing mission similar to Enola Gay's. Also, the weather conditions were favorable. He believes that at the last moment they opted for an act of clemency and dropped their weapon on an uninhabited area. And now let's get into theory number 2. Another theory puts the blame on a failed experiment by Nikola Tesla. This is related to one of his projects, the Wardenclyffe Tower, which stood 60 meters or 187 feet tall and was located on Long Island in New York. The purpose of the tower was to facilitate worldwide wireless communication and to deliver electrical energy over great distances. This was something Tesla had achieved on a smaller scale with his coil. The project was scrapped when financiers backed out. However, the theory goes that around the Tunguska event, explorer Robert Peary was on an expedition to the North Pole. Tesla contacted him before the trip and asked him to report back on anything unusual he encountered. So, could Tesla have fired a blast of energy at the uninhabited North Pole and missed, perhaps hitting Tunguska instead? This theory aligns with those who claim that Tesla's Wardenclyffe Tower was an operational superweapon, a death ray. Tesla claims that he did design and test a similar device later in his career, a beam projector called Teleforce. But all of this is pretty much science fiction, so let's step away from that and go to theory number 3. In 1973, a paper was published in the journal Nature suggesting that a black hole colliding into the Earth caused the explosion. The theory was put forward by the Center for Relativity Theory, University of Texas. A small black hole descended upon Tunguska, created the craterless impact, sped through the Earth, and then exited the planet in the North Atlantic. To validate the theory, all it would take is to investigate the bottom of the ocean for an exit wound. Nobody has ever financed that expedition, and the theory has been widely discredited. Along the lines of theoretical physics, another hypothesis suggests that the Tunguska event could have been the result of matter and antimatter colliding. When this happens, the particles annihilate and emit intense bursts of energy. Also, this theory has remained unproven. Following Kulik's expedition, Russian researchers were puzzled by the lack of craters and alien rock fragments at Ground Zero. They tried to explain this by positing that it was the icy fragment of a comet which caused the damage. Comets are largely made up of ice, and it is possible that a large block detached from a larger body and plummeted to Earth. The ice would have evaporated violently as it entered the Earth's atmosphere, causing the blast. An opposite theory emerged in the 1960s: fire from the Earth. Verne shots, named after author Jules Verne, are speculative magma reactions that violently erupt from underground. A magmatic intrusion beneath Siberia may have formed a large bubble of trapped volcanic gases. The covering rocks shattered, and bursts of burning methane caused the series of explosions that was described by witnesses. But geologists mapping the area found no traces of shattered rocks or gas vents. So this leaves us with theory number 6. The obvious explanation was that a meteorite made of rocky material had exploded before hitting the Earth's surface, like Krinov had theorized. This explains the lack of a crater, but we've still got the problem of the absence of fragments. In 2013, a team led by Viktor Kvasnitsia of the National Academy of Sciences in Ukraine put a stop to all of the speculation. The researchers analyzed microscopic samples of rocks collected from the explosion site in 1978. The samples were found to be of meteoric origin and were recovered from a layer of peat dating back to 1908. So the fragments were there, but nobody had thought about looking for the very small ones. The fragments are traces of lonsdaleite, a mineral known to form when a meteor crashes into Earth. Kvasnitsia stated, "We believe that nothing paranormal happened at Tunguska." Alright, but the alien bombing theory has its merits, right? We believe that nothing paranormal happened at Tunguska. Alright, but Tesla, he's gotta have something to do with it, right? Alright, yes, nothing paranormal happened at Tunguska. Today, the consensus is that the Tunguska event was caused by a large meteor colliding with Earth's atmosphere. First, the cosmic body entered our atmosphere at about 15 kilometers per second. That's 9 miles per second. Our atmosphere is a great protective shield, generally successful in breaking up rocks a few kilometers above the Earth's surface, producing an occasional shower of smaller rocks that, by the time they hit the ground, will be cold. These large cold fragments are the ones that normally dig up a crater. But in the case of Tunguska, the incoming meteor may have been extremely fragile, or the explosion so intense that it obliterated all its remnants about 8 to 10 kilometers above the Earth. This process explains the event's second stage. The atmosphere vaporized the object into tiny pieces, while at the same time intense kinetic energy also transformed them into heat. The sudden release of heat accounts for all phenomena observed by eyewitnesses and scientists: the powerful blast, the extensive shockwave, the forest fires, and the absence of a crater. But just think about that. Just think about that 15 kilometers per second. That's 900 kilometers per minute, 560 miles per minute. The meteor could have flown the whole width of the US, coast to coast, in about 5 minutes. It would have taken just a few extra seconds for the meteor to hit a less desolate area. What would have happened if humanity hadn't been so lucky on that day? The explosion caused one victim, of course one too many, but it could have been a catastrophe of a much larger magnitude. The meteor was assumed to be 30 meters wide, its mass estimated to be 42 million kilograms or 93 million pounds. Based on these parameters, you can calculate the total energy released by the explosion via the formula in the caption below. And no, I'm not going to try and read that. Assuming half of the energy is dispersed to noise, attrition, and fragmentation, the explosive energy is still the equivalent of 500 kilotons of TNT. That's 60 times the explosive power of the bomb dropped on Hiroshima. Other accounts claim 185 times, but let's stick to the conservative estimate here. The projectile traveled in a southeast to northwest direction. A quick look at Google Maps will show you that the land northwest of Krasnoyarsk is still sparsely inhabited today. But if any Russian viewers would like to confirm or dispute that, please do use the comments. Depending on how the object traveled, though, you could draw a straight line from Krasnoyarsk to St. Petersburg, the then capital of the Russian Empire, which is located about 3,600 kilometers or 2,200 miles away from the site of the impact. But what if the object had traveled at a slightly different angle than the 60-degree azimuth estimated by researcher Fezenkov? This is the angle between the trajectory of the flying object and the Earth's surface at the point of impact. At a different angle, and with its speed, it would have only taken about 4 additional minutes for the object to reach St. Petersburg. This is a city which, according to a 1905 census, counted 1.6 million inhabitants. I'll leave it to your imagination what the effects of 60 Hiroshima bombs hitting an urban area with such a population would do. The blow on the Russian Empire, though, it would be devastating. The enormous death toll would leave an enduring scar on the country, victim to the largest loss of life in one single event in the history of humanity. And what about the effects on the history of Russia? Around May and June of 1908, Tsar Nicholas II and Tsarina Alexandra were in the Baltics, hosting a visit from the British King Edward VII. We don't know their location, but on the 30th of June, let's assume they were at sea and they survived. The rest of the political leadership might not have had the same luck. The destruction of St. Petersburg would obliterate the Fourth Duma. This was the parliament instituted after the 1905 revolution, and its fourth term was a conservative assembly with little representation of opposition and minority groups. The St. Petersburg events would radically modify the makeup of Russian society. Nicholas's leadership was already on shaky ground after 1905, and the tragedy of June 1908 would decapitate the political class that was supportive of his rule. This may result in a quicker version of the 1917 revolution. Veterans from the 1905 uprising may take the opportunity to establish separate government and assembly in Moscow, ousting the Tsar. A Russian civil war may ensue, like in our timeline, but maybe without any foreign intervention. France and the UK were tied to the Russian government, but these were defensive alliances against Germany, so maybe they would not intervene to support the Tsar. Plus, unlike our timeline, the French and British armies were not fully mobilized in 1908. Could this have resulted in a consolidated Soviet Union several years ahead of schedule? Alternatively, what if the St. Petersburg event spurred a unitarian movement in Russia instead? What if the other European countries rallied together to provide humanitarian aid to the stricken empire? What if the British and Germans set aside their naval rivalry pre-World War I to better assist Russia? So I realize we went from science fiction to science and then back to science fiction again, so I'm just going to stop here. If we have any alt historians in the audience, please write your scenarios in the comments below. We'd love to hear from you. And now we just have to ask, when can we expect the next Tunguska? Well, one already happened on the 15th of February 2013 when a smaller meteor burst in the atmosphere near Chelyabinsk in Russia. This event created an opportunity for researchers to apply modern computer modeling techniques to explain what happened. Based on the current knowledge of the asteroid population, an object like the Chelyabinsk meteor can impact the Earth every 10 to 100 years on average. That's quite a frequency, but the blast of this meteor was less violent than Tunguska's, resulting in an estimated 1 million broken windows and several injuries, none of which were fatal. But what about the larger rocks, like the one that hit Tunguska? By combining clues from the magnitude of that event with the most recent asteroid population estimates, NASA researchers have concluded that the average interval between such impacts is on the order of millennia rather than centuries. Still, NASA's advice is to remain aware and prepared for such a hazard. Asteroids have hit the Earth, and more asteroids will hit again. The systems NASA is developing will ensure we can better prepare for dangerous impacts. Here are some words of reassurance from Lorian Wheeler, a researcher working on NASA's Asteroid Threat Assessment Project. Because there are so few observed cases, a lot of uncertainty remains about how large asteroids break up in the atmosphere and how much damage they could cause on the ground. However, recent advancements in computational models, along with analyses of the Chelyabinsk and other meteor events, are helping to improve our understanding of these factors so that we can better evaluate potential asteroid threats in the future. Tunguska is now considered an astronomical cold case, but forensic research on the event is inspiring modern-day investigators to mitigate future threats. Thinking about a potential forthcoming impact, I would venture a piece of advice to NASA or the ESA or whoever will save the world, and that's to not take inspiration from Hollywood. Instead of taking some oil drilling experts and teaching them to be astronauts, isn't it easier, quicker, and cheaper to take the astronauts and teach them to drill and plant explosives instead? So that's it from me today. Please do leave your comments, corrections, of course, and alternative scenarios in the comments. And as always, please do hit that like button, hit that subscribe button, and thank you for watching.